My role is the Director of Solutions Engineering, so I spend a lot of time with our customers trying to help solve various different types of problems, one of which we're going to talk about today with automated health monitoring tools. We're going to focus on a particular application that we have in our platform called Performance, and we'll go through a few different kind of perspectives of how to look at what performance means. We're going to talk about who does performance matter to. We're going to look at the data that is produced in creating data-driven approaches. We're going to look at some of the measurement areas that you can focus on, and I have a quick video at the end of just what the platform looks like, so this isn't just necessarily me talking with slides. We have a quick little 1-minute video that hopefully will play properly. So just quickly, if you're not familiar with Miovision, Miovision has been around for about 18, 19 years now. We developed a product that uses video-based analytics, video-based detection for mainly the intersection, turning movement counts, mid-road, mid-block type road data collection counts. If you want to see our tool sets, we have a booth just over in the midway there, and you can see the scale product and our permanent data collection tools. We do have a series of different applications. Detection and counts is our main one, but we do have adaptive performance, portable devices, and priority control type technology all embedded in the same device. And we focus a lot on improving optimization for both safety and progression through corridors in a few different ways. So I'll take you through some of that right now, but right before I get into that, let's talk a little bit about who cares about corridor progression, who actually is impacting corridor progression, and what does that actually mean to different stakeholders around this. The obvious role that interacts with this type of problem is often the traffic signal engineers. They're often looking at, how do I optimize a corridor? How do I get people back and forth from work or to malls, whatever it may be, and how do we optimize corridor progression? But there's a few different ways you actually accomplish that. One is actually the physical infrastructure itself, having proper timing plans, having proper equipment, having functional signals. A signal in flash or not operating is an obvious reason why no one can get through a traffic corridor. If detection is failing, how is that actually operating? So the signal technician needs some tools to help corridor progression. The signal engineer is looking for tools to help create the optimization as well. Then you have the management layer. They're trying to create strategic opportunities, trying to measure that return on their investment. Are they actually making those improvements? Then there's the entire political landscape of the citizens and the politicians trying to advocate for different types of road users like bikes, pedestrians, trucks, moving through the network and so on. So how do you actually create corridor progression when there's so many different types of stakeholders and different types of users on the road? So we integrated and created a platform that creates real impacts through a data-driven approach by surfacing up the right data that actually gives you the tools to not just look at a sea of data, but actually get insights out of the information you're looking at so you can get to action quickly. More data often gets that perception that you don't have an unlimited amount of time to look through data, and you get that perception or that feeling in your gut that it's just too much data to go through. So we need to create a platform that gives you suggested improvements, that helps you get through all the big data that is generated through it. There's also a workflow that you go through to actually create corridor progression. You don't just jump to, oh, let's optimize the signal. You have to start more with the basics and work your way up what we often think of as a hierarchy of needs. We refer to it in our system as the hierarchy of needs of the traffic signal operations. And that first bottom layer is the equipment inside itself. Is the hardware working the way it should? Am I getting the right data? Am I actually looking at something meaningful here? And then you go up a step, you look at the maintenance. Is the signal operating the way it should? Do I have insights on things that are broken? Is it actually operating the way I planned it to be operating? Then you have operational and performance insights as you move up the stack, where you're actually looking at, is it doing the time of day that I expected it to do? Is there congestion not being surfaced in a way that it's actually being solved? Really allowing you to put all the data at your fingertips to work through that workflow of starting with the basics all the way to the complex optimization. Often for all of us, the issues start with citizen complaints. So how do you actually start with the data set? how do you try and get ahead of it, be proactive in the data to actually find the problems before someone complains about it, but then if somebody does complain, respond to it faster and better and quicker, ultimately saving you time and money, solving your problems without digging through a sea of data. Congestion management is the obvious point of improving improved corridor progression, but there's a lot of great benefits that come out of that when you actually do create the optimization. Obviously, safety and time is a big part of that. So delay being a big measurement in the platform to actually show you what is the delay, where is the delay, and how is it actually being impacted. And many of these tools can be used as a before-after analysis of actual tool sets to create that optimization. Emissions is a great way to, when you impact delay, you impact emissions and you impact fuel consumption simultaneously, and being able to report on those tool sets pretty rapidly. So having before-after study approaches where you can look at your data, what it was before, did you make the impact afterwards, what are the trends of that happening in your corridor all simultaneously, and then creating nice reports to understand that quickly. Improved safety is always a number one in everyone's mind, and if anyone's been stuck at a traffic signal that is too long, or there's too much congestion, or you're stuck somewhere, you start taking liberties, you start rushing the reds, and you try to enter the intersection where you shouldn't because the timing is not working the way it should. So just improving the operations of it will limit the drivers from making their own choices. Keeping technicians off the road when they don't need to be on the road by getting proper insights will just keep the staff operating the intersection safer as well, ultimately creating a better, calmer corridor for safety along the way. As many of you may be thinking, ATSBMs do mean a lot of data, and one of the challenges is capacity. Not every city has an unlimited amount of capacity. You can't just keep taking in more data and expect you to have more time to use data. So creating a tool set that surfaces up those insights in a much better way so that you can get to action quickly. So to get into the actual tool set, Miovision One platform is the tool set that we provide our customers. The actual application is called Performance. It has a map-based insight priority view where you're looking at that hierarchy workflow of what are my maintenance problems first, looking at what is degraded, what is significantly delayed, what is causing impacts to my corridors at a network view. Not every intersection or corridor is treated equally, so focusing on your priority corridors for, say, AM, PM peak time, and addressing those problems as they come up in a priority order, but also having a holistic view of where the problems are. If you're going to send a technician out, you might as well solve all of the problems in that region at the same time, especially if you're going to waste 2 to 3 hours just to get across the city to solve more problems. Looking at where in the network is the problem actually coming from is also a very important step of the process. Often you get a complaint from an intersection in a corridor, but the problem may not be coming from that location itself. It may actually be stemming from an intersection that's down the road or up the road in a way that is causing pain at adjacent intersections around it. So being able to assess the travel time, the impacts more holistically, where in the network is it slowing down, causing the spillback effect where problems and impacts are actually occurring further down a corridor, and really heat mapping that out of where those problems are existing. When you look at a large set of data, often you don't want to look at a single set of data or a single day. How does that trend look over a larger period of time? Is it the same every day? How's weekends versus daytime or weekday? How's weekend versus weekday? And when in the months are they different? There's school in, school out. How is the traffic changing over a longer period of time and throughout the week? And looking at a more holistic trend of data that's occurring. You don't want to just solve a problem for one particular complaint, but cause 7 more problems further on down the road that you then, again, don't have time to solve. So how do we give you a better, more holistic view to actually solve that problem? When you surface up all this information, you get some nice performance insights that help you implement the right strategies, whether it be using free modes or better coordinated modes, or adjusting your start or your end times, creating better phase splits that actually address the demand at particular movements at any given time, and surface that information up in a way that you can solve the problem quickly. The last set of reports is actually start translating that data to a meaningful data point that the public would understand. As traffic engineers, we spend a lot of time thinking about the level of service, which means a lot to us as traffic engineers. But when we actually go to speak to the public, I can't just say your intersection's a level B, so you're doing okay. The public won't know what that means. So translate that to time cost that's stuck in the network, emissions cost, fuel cost and an annualized impact financially, because saving them time means more money, less emissions, and it actually translates to a much larger impact to the public when you're talking about the impacts that you're making. And let's see if this works quickly here. This is a quick little video. Oh, sweet, it works. It is a quick little video here that just takes you through what the user interface looks like, how you would interact with some of those slides I was just showing, focusing on individual intersections or assessing a particular problem. You can click on one of those pieces of information, see what's more severe, what's less severe, click into a particular problem. What is the maintenance insight that is telling me I'm having detector issues, whatever it may be that's causing a slowdown in the network, get right to the data as fast as possible and review those functions to get to the solution. Look at the larger data sets in an easy interface where you can see where is the volumes, where is the vehicles arriving, where is delay occurring throughout the network, and keep diving deeper down the data set so that you fully understand holistically what is causing a problem, where is the problem, which movement is causing it, and start addressing it with the right timing plan adjustment or the right strategy of improving the particular corridor congestion problem. So we call this our performance measure tool set that allows us to do in an automated way, automated performance measures built in and layered into your city infrastructure. So that's our platform today, and please let me know if you have any questions. I'll be at a booth just over there if you want to come by and say hi and see a more interactive demo, but thanks everyone.